Hello, it's me, Mr. Hilbert, your geometry teacher. Um, so I'm not here today, but I'm going to show you how to solve for arc length and area of a sector. Now, my younger son and wife are giving Biscuit a bath, so they're making a lot of noise. I don't know where my older son is, but he'll end up coming in here and doing something annoying, I'm sure. So just try to bear with me. All right, great. So you should have this piece of paper. This is my home. Welcome to my home. This is just the kitchen and the dining room. We're working on a puzzle over there. There's some dirty dishes, coffee maker, a bunch of mail that I'm probably supposed to be answering. Anyhow, okay, so this sheet should be in front of you. Solving for arc length is very similar to solving for area of a sector. Now, neither your book nor this Gina Wilson geometry curriculum includes area of a sector. I don't know why, but I will show you how to do it. It's almost exactly the same as arc length. So, remember we have a central angle, and that central angle's degrees is equal to the arc measure. Arc measure is different from arc length, okay? The way to solve for the length of this arc is to take whatever that central measure is, put it over 360, and set it equal to the length of the arc over the full circumference. Okay? And I'll do an example here in a second. But this is your basic formula. For both of these, for arc length and area of a sector, your first ratio is x over 360. It's always the central angle over 360. Okay? So for area of a sector, we have x over 360 is going to be equal to the area of a sector over the full area. Okay? So think part over whole is equal to part over whole. So this part to whole is going to be the angle over 360 because 360 degrees is the full circle's measure. And then this part to whole is the part we're looking for, either area of a sector or arc length over the entire circumference or area. Okay, let's do an example. So I didn't fill in this arc length formula. You can just put this over there if you want. So for these first four, I want you to find both arc length and area of a sector. After that, you just need to find the arc length, okay? So I'll do number one. Our radius is 6. So we already know that our first ratio is 107 over 360 because this arc is created by the central angle of 170 degrees. 107 degrees, sorry. So that is going to be equal to our arc length, which we'll just make x because we don't know it, over the circumference. To find the circumference, we do 2 pi r. R is 6, so that's going to be 12 pi. So whatever 12 times pi is, it's going to be 37 point something. So we'll just say it's 37.4. I don't know. I don't have a calculator. I forgot my calculator. Actually, somebody took it, so I can't find it. And now to solve, we just cross multiply. So we end up with 360x equals whatever 37.4 times 107 is, and then we would just divide by 360 to get your answer. Now, to find the area of this sector, we again do pretty much the same thing. 107 over 360 is equal to the area of a sector. We'll make it y so as to not confuse it with arc length, over the entire area, which is going to be 36 pi. Pi r squared, r is 6, r squared is 36. So once we do that math, 36 pi, we'll get some sort of decimal, cross multiply, and solve for y. That is how you do arc length and area of a sector. It is not terribly difficult. You should be able to do this, and you should work with people in the class. If you need help, you better be good. If you're not, you will get points. I think we're all looking forward to seeing me again on Biscuit's back. He's got his bat. Oh.